I am going to do my best to help you with preparing for a lot of the math the quarter one exam that we'll be taking. And the first thing we'll start off with is you'll need to use your resources in your binder, and that will be provided on the exam. And if you have these three parameters, you have turbidity with a weighing factor of 0.08, temperature weighing factor of 0.1, and dissolved oxygen or DO at 0.17, you can go and calculate by using the NTU values. You'll find that using 32 centimeters has an NTU value of 21. And if I use this on my Q value chart, I find that it should be right at 60. For temperature, I find the difference of 0.6. I'd use 0.6 on my Q value chart. It's about 91. It's definitely over 90, so I'm going with 91. And for dissolved oxygen, you have to make sure that you align 5 parts per million. You put a dot on the 5 parts per million, and you put a dot on 15 degrees. That is my average temperature here. I connect the dots. I get a value of about 52. This is my saturation percentage. And then I take my 52 value and I correspond it onto the Q value chart, and I get a 47. From here I have my Q values. I take 60 times 0.08. I get this value. 91 times 0.1. I get this value. And 47 times 0.17, I get this value. I think that value there was 7.99, but close enough to 8. I add these together, and I get a value of 21.9. But this 21.9 only represents 35%, and I get 35.35 by adding up my weighing factors. So here, I take 0.08 plus 0.1 plus 0.17. This is my denominator, and I find that it's 63%. Therefore, my overall health is going to be medium at 63%, and I'll provide the qualitative explanation for percentages tomorrow. That'll be on the exam. And if you notice, the healthiest was temperature, and the least healthy was dissolved oxygen. And remember, dissolved oxygen has a high weighing factor, so as a result, it's going to bring this overall average down. Moving on, more math. A student takes off from Chicago and travels 4 degrees south and 3.5 degrees east. How far did she travel? How far east did she travel? South, then how far east? What is her net displacement? And what are her new latitude and longitude coordinates? So I can do this. I did the math for you. From Chicago, she travels 4 degrees south. I know that 4 degrees, each degree, it's 69 miles per degree. So 4 degrees times 69 miles is 276 miles. She travels 276 miles south. At this point, I'm now at 38 degrees north. I travel east, and I find that Table 1-1, it's 54.578 miles times 3.5 degrees east. I get a value of about almost right at 191 miles. So traveling along the 38 north parallel, it is 191 miles, and this should be east. And then I find my resultant displacement. I have two sides of a triangle. I have 276 south. I have 191 east, and I get my net displacement here. Hypotenuse is going to be the square root of 276 squared plus 191 squared, and I find that it's 336 miles southeast as my net displacement. And then my new latitude longitude coordinates are going to be started off at Chicago. I've traveled 4 degrees south, so it's now 38 degrees north of the equator. And I've traveled 3.5 degrees east, so it's 3.5 degrees closer to the prime meridian. So 88 minus 3.5 gives me 84.5 west. And these are my new latitude, longitude coordinates. Here I've got a student gets on a plane on Wednesday in LA, California, 5:45 p.m. to fly to New York City. The flight takes 5.5 hours. Well, how many time zones were covered? Well, if I look at the picture, they go from the Pacific to Mountain to Central to Eastern. So we're really talking about 4 time zones: Pacific, Mountain, Central, and Eastern. However, how many hours different is the Pacific coast from the East Coast? Well, in this case, it's only 3 hours different. If it's 5:45 in California, it's going to be 6:45 Mountain, 7:45 Central, and 8:45 p.m. local New York time. Remember, it's earlier. It's only 3 hours earlier, but notice the time zones. You have to make sure you're paying attention to what's happening with times. So it's 8:45 p.m. upon taking off. So what's the local time in New York City when the student arrives? Well, 8:45 p.m. local time with departure plus 5.5 hours shows I can solve this. Add 8:45 plus 5.5, or 5 hours 30 minutes, is 2:15 a.m. the next day. So that would be 2:15 a.m. on Thursday arrival. Next one, time zones. Let's say I'm on a boat. It's noon at 40 degrees east. This is going to be my reference, and I tried to color code these so I can do them one at a time. So what is the solar time at each of the following locations? So 50 degrees east. So I did the first one in black. 50 degrees east is another 10 degrees further east. So 10 degrees times 4 minutes per degree is 40 minutes later, right? 50 degrees east is east of here. So I'm finding solar time here. So what is the solar time? It's going to be 12 noon plus 40 minutes, which is 12:40 p.m. And that's what I solved here. 40 minutes later, it's 12:40 p.m. solar time. The second one, for 90 degrees west, this one here is in red. So 90 degrees west is, notice it's on the other side of the prime meridian. So I add 90 degrees plus 40 degrees is 130 total degrees. And I know that for every hour, it's 15 degrees. So this is my ratio I'll be calculating, or my proportion. So 130 divided by 15 is 8.6 repeating, which is actually 2/3. So it's going to be 8 hours and 2/3 of an hour earlier. So I take 12 noon minus 8 hours and 40 minutes, and it's going to be 3:20 a.m. in terms of the solar time. And that means, so 3:20 a.m. is the proper time. And remember, because it's west, it's going to be earlier. It has not had the noon sun yet. It's awaiting the noon sun. The sun would still be rising. Lastly, in pink, 25 degrees west. Let's see here. 25 degrees west is closer to the prime meridian. So 25 west plus 40 east is 65 total degrees times 1 hour over 15 degrees, which is 4 1/3 of an hour. So 4 hours and 20 minutes. It's 4 hours and 20 minutes earlier. And as a result of that, I take 12 noon minus 4 hours 20 minutes, and I find that it's 7:40 a.m. solar time at 25 degrees west longitude. So, I hope your ship has not sailed. It is 11:15 at 15 degrees east. What is the solar time for a ship that is located 15 degrees west? Well, I do the picture right here. 15 degrees east, it is 11:15 a.m. What time is it over here, solar time? Well, notice that it's 30 degrees difference. So 30-degree difference, and I know for every hour is 15 degrees, so it's 2 hours earlier west of the prime meridian. It's earlier, and 2 hours earlier, so it is 11:15 minus 2 hours is 9:15 a.m. And my second problem is 3:30 p.m. at 52 degrees west, 3:30 p.m. So what's the solar time at 20 degrees west? Well, notice it's a difference of 32 degrees times 4 minutes per degree, and I get a total of 128 minutes. 128 minutes is 2 hours and 8 minutes later. It's already experienced the noon sun. So, or it's already experienced this time. It's already experienced 3:30 p.m. solar time. So I take 3:30 plus 2 hours and 8 minutes, and it's 5:38 p.m. solar time at this new location. Cranking on through. Moving on. Rise and shine, Porcupine. Sunset in Chicago is around 5:45 p.m. this time of year. So what time does the sun set in Detroit, Michigan? That's 42 north, 83 west in Eastern Standard Time. Well, here's Chicago. It's 5:45 p.m. Here's Detroit, which is 83 west. Notice it's a difference of 5 degrees. So 5 degrees times 4 minutes per degree, that's 20 minutes earlier. Yet it's one time zone later. So I take my clock time, 5:45 minus 20 minutes is 5:25 p.m. in Central Standard Time. But that's 6:25 p.m. Eastern Standard Time. So that would be 6:25 p.m. Eastern Standard Time. Sunrise in Chicago occurs around 6:30 a.m. Central Standard Time. What time does the sun rise in Boston, Massachusetts? That is 42 north, 71 west. Local time, Eastern Standard Time. Well, Chicago is 88 degrees west. Boston is 71 degrees west. That's a difference of 17 degrees. 17 degrees times 4 minutes per degree is 68 minutes, which is an hour and 8 minutes earlier. Yet it's one time zone later. So that's actually going to be 6 minutes earlier. So 6:30 minus 8 should be 8 minutes, 8 minutes should be 6:22 a.m. And that's your sunrise time. And last, not last, flying overseas over numerous civil time zones, an airplane takes off from O'Hare at 10 p.m. Beijing, China, and it's 116 degrees east, 40 degrees north. If it takes 13.5 hours for the flight to travel from Chicago to Beijing, what time is it in Beijing when departing? Well, I can do this by doing the math. I know that the prime meridian's right here. I've got Chicago is 88 west. I know Beijing is 116 east. I add them together. I find it's 204 degrees of total longitude distance. Times, I know that 1 hour or one time zone is every 15 degrees. Comes up to a value of 13.6, which is 14 time zones. There are no partial times for time zones. So it's 14 time zones or 14 hours later. So if I am leaving at 10 p.m. in Chicago, it's going to be 14 hours later. That means it's going to be noon on Tuesday in China, in Beijing. So that means if it's 12 p.m. the next day, that would make that Tuesday. So notice, if it's 12 p.m., I then, in Beijing, I now add 13.5 hours of flight time, which is going to be 1:30 a.m. even the next day, which will be on Wednesday. So I arrive at 1:30 a.m. on Wednesday in Beijing, China. And last but not least, finding slope. So a student walks, I tried to draw you pictures here of what it's trying to communicate to you. A student walks from the parking lot from the shore of Lake Michigan and travels downhill a total of 50 feet while walking a distance of about a half a mile. Find the slope. So notice they walk down this along Lake Shore. They walk down 50 feet while they walk, or their rise versus run of about 0.5 miles. Notice 1 mile is 5,280 feet, and these are not drawn to scale. Neither one of them are. So walking downhill, notice it's going to be a negative slope, and I didn't put it in here, but I did put it in over here. It's a negative slope. You're walking downhill. You are losing elevation. So a half of a mile run is going to be 0.5, half of 5,280 feet, which is 2,640 feet. So I travel a slope is going to be negative 50 feet over 2,640 feet. So I could say this as a slope as a ratio of 50 feet, of a downward 50 feet for every 2,640 feet run. But that's not simplest term. So I could simplify, I could divide both sides by 50 and get negative 1 feet per 52.8 feet. And I could even further divide this even simpler, divide both sides by 52.8, and I would find that it's negative 0.02 feet per 1 foot I walk horizontally. So my first one is going to be my rise. In this case, it's dropping in elevation. It's a ratio to run. And that's how I solve this one. So this one's walking downhill, and it's going to be a negative. It's going to be negative values. And here, my second problem is a student walks from the lakefront to where the car's parked. That's 120 feet higher in elevation and above Lake Michigan. So the horizontal distance is 0.25 miles. So what's the slope of the walk to the car? So they start here and they walk up this hill, and they end up here at their El Coche, which is French for automobile. So they walk up 120 feet, and they walk a run of 0.25 miles, which is one fourth of 5,280 feet, which is 1,320 feet. So now I have a ratio, 120 feet up, positive value, for 1,320 feet run. I can divide both sides by 120 feet. I get 1 foot per 11 feet. And I can divide both of these sides by 11 to find that 0.1 feet, right, for rise. Every 0.1 feet I go up, I move over a run of 1 foot. And that is how you solve the math for our exam tomorrow.